Hi everyone, in this video I'm going to show you how to perform a flash loan using a library called Money Legos. And in this example I'm also going to perform a very basic arbitrage against a couple of cloned Uniswap applications. So starting off, if we take a look at the Money Legos website, you can see here that it describes itself as being a package that provides you with mainnet addresses, ABIs, and Solidity interfaces for popular DeFi protocols. What do they mean by that, and what do they mean by Money Legos? Well, the idea is that a Lego is something you can piece together to make something else, and the Lego in this case are the protocols that make up the current DeFi space. Over here on the left, you can see some of the protocols supported by Money Legos, such as Compound, DYDX, Kyber Network, Uniswap, and so on. And this library, the Money Legos library, makes it nice and easy to basically piece together these different protocols to make your own DeFi product, essentially. So what I've done in this video, and there is a link below to a repository, is I've put together an example that uses the Aave network here, the Aave protocol, to basically perform a flash loan. And then I'm going to make use of the Uniswap protocol to basically perform an arbitrage against a couple of Uniswap exchanges, which have been cloned by another developer. Links to all of these things are going to be in the notes below. So what I did was I followed the quick start, and I went through these examples, and I went through the Solidity example, and I went through the JavaScript example to put together a working example that performs a flash loan and an arbitrage. So let me walk you through the steps quickly over here. So as you can see, I've got a repository, and this is basically a new truffle project, and I've also run an npm init to produce the package JSON here. So truffle initialization produced a truffle config. I've already exposed the development network and the Coven network. I'm not going to go into that in too much detail because I want to focus really on using Money Legos. But I'll just explain and show you here the dependencies. So I'm obviously using the Money Legos library. I'm using Truffle Wallet. I'm using the Ethers JavaScript library to interact with the blockchain. Ethers is another alternative. It's an alternative to Web3.js, and of course Truffle. What else am I using here? Well, I've got basically the usual folders here: the contracts, the migrations, and in source, in the src directory here, I've got the a TypeScript file which basically will execute my contract. So let's go into the contract itself. So this is the contract here. I'm calling it Flash Loan Money Lego. So what I'm going to do is, I'm not going to do actual typing. I'm going to do a bit of copy and pasting, actually. So the first thing I'm going to show you here is the basics of importing the libraries that we need from Money Legos. So that's how we import the Money Lego contracts, basically. And you can take a look at that in your own time. I'm also, of course, importing the interface for the ERC20 token. Now, the next part I want to go through is basically the contract itself. So what I'll do is I'll create the contract, and I'm going to start off with the loan. So I'm going to write the entry point for the flash loan, and that method looks like this. So you may recall from the previous videos that this is pretty much the same as the other examples that I've gone through, except this example I've taken from Money Legos, but actually there's not much to it, and I'll let you go through this in your own time to really understand it. Take a look at the other video where I cover flash loans using the Truffle box. It's essentially a flash loan against a lending pool from Aave protocol, and we perform the flash loan here. This part here is because we're actually going to perform an arbitrage in the actual execute function, the execute operation function, which I'm going to show you in a second. And this basically says, okay, well, if there's any DAI left in our contract, that's profit, so let's transfer that back to the sender. All right, so on to the execute operation. This is the meat of the contract. This is where we actually perform the arbitrage. So again, there is a repo which you can look at and go through this in your own time. But I'm going to just run you through this very quickly. So when the flash loan is complete and applied to the contract, the execute operation function is then called. And what we do is we basically perform a flash loan against a couple of exchanges. Now, it's probably a good idea at this point that I also include all the addresses and the interfaces and the constructor to complete this contract so that we get a sense of where things are coming from. So here is the constructor. And what we're doing here in the constructor is I'm basically having to override the address provider. This is because the address provider in Money Legos is the address provider for the mainnet, and I want to use my own address provider for Coven network, which is this address right here at the top. So I'm overriding that first of all, and then what I'm doing is I'm creating two Uniswap factories from the Uniswap interface, and these two addresses here are deployed factories on the Coven network that we can use to test arbitrage. I then go ahead and create our, or basically fetch the exchange address for BAT. And I'm getting the address for BAT from exchange A and from exchange B. And the reason why I'm doing that is because I want to be able to try out exchanging between the two different exchanges, just in case there is an arbitrage opportunity on one side or the other. As it turns out, when I recorded this video, we can see that the arbitrage works with a profit when basically converting DAI to BAT via exchange B, and then selling the BAT coin back to DAI on exchange A. So just having both exchanges available as variables like this, and then creating actual exchanges here for both exchange A and B for both BAT and DAI, allows me to easily experiment and change the order of the trade. Okay, so I'm going to go down into the actual execute operation, and here I'm creating my exchanges for what I call the reserve address. Okay, now what is the reserve address? Well, it's the value that's passed in here, which is basically the value of the asset that we want to borrow, which was set here. So the asset to flash loan is the asset we want to borrow. And in a minute, I'm going to basically fill out the JavaScript or the TypeScript example that will execute this smart contract on the Coven network, and the asset that I'm going to pass in is going to be DAI. So I've left it like that to be a little bit dynamic so that we can try different reserve addresses and different assets to start off with, but I know that this is going to be DAI. So I basically create the addresses to be able to trade DAI coin in both exchange A and exchange B. Okay, this part here is the fun part where we start the actual swaps. So when you're performing a swap on Uniswap, you have to ask for approval first of all, and it could be rejected, maybe because of liquidity reasons. So basically we need to approve it first, and we wrap that in a require statement so that we don't proceed any further, because there's no point to proceed if the approval is denied. So we approve the request to swap the coin, and then we perform the actual swap. And what I'm doing here is, as I mentioned before, I am using exchange B, okay, to swap my DAI coin. So this is the token to token swap input function. And I'm passing in the full amount of DAI that I borrowed in the flash loan. That's what this underscore amount value is. And that is the value that's passed into this function here when the flash loan has been completed. So it passes in the amount of the flash loan that's been assigned to this contract. So I'm basically saying here, please swap all of my DAI that I've borrowed for backed coin and use exchange B to do this, okay? Now these numbers here, 1 and 1, these parameters are basically related to slippage. We're not going to go into that right now. And there's a deadline which we can just ignore for now. This is related to how long this trade should be valid for. The main thing is that we want to know that we are swapping our DAI coin for backed coin. And then immediately after that, I'm going to head over to exchange A, and I'm going to firstly ask for approval and get the approval. And then I'm going to exchange my BAT coin that I just purchased here and exchange it right back to the reserve coin, the coin that I bought, which is DAI. So essentially I'm saying here, please exchange or swap my BAT coin back to DAI coin. Okay, what I do here is a quick check on the debt. So the debt is basically the principal or the amount that I borrowed in the flash loan plus the fee that I have to pay for the flash loan. And then I do a quick check here to make sure that I have indeed got more money available than I need to pay back. And if not, then it will just revert and the transaction will end. Otherwise, I've clearly made a bit of a profit, so I transfer the funds back to the pool. This is an internal method that is part of the Aave protocol, and it's provided by the Money Legos library that we imported up here. So it's part of the flash loan receiver base, right? That's right here. We import it there. So that method comes from there, and that basically just returns the DAI, the reserve coin, which is DAI in this case. It returns that amount plus the fee. And that keeps the lender happy, right? And then, of course, this keeps me happy because it transfers the profit at the end to my wallet. Okay, so I hope you followed along with that, and check out the repository to see this code and run this code for yourself. So let's have a look now at running the code. Now I will migrate the contracts to the Kovan network. So migrate, reset. And it's going to first compile these contracts, and it's successful, and now it's going to migrate. Great, the contracts have migrated now to the Kovan network. We can check that with networks. You can see here the deployed contract address. Now, there are several ways that we can interact with this contract. One way, of course, is using the Truffle console where we are right now. And another way is to use a JavaScript library. And this is another way where the Money Legos framework and library of components basically shines, because they also provide a JavaScript API as well. If we take a look at the README file, you'll see that there is a section here on interacting with the contract via the Truffle console. I'm not going to go through this in this video because I'll leave that up to you guys. But basically you can see it's similar to what I did before in the previous video, where we grab an instance of the contract, we set the asset that we want to loan, which is DAI, and this is the address from the Aave network. We want to borrow one unit of DAI, which the unit, of course, has 18 places. And and so on. So we can basically, you know, follow this to interact with the contract. But I've also provided in this repo a way we can interact with it using TypeScript. And the TypeScript example is in the src directory. It's called exec flash loan money Lego. And the way to execute it is you need to install TypeScript, and you can install this ts-node, which allows you to run TypeScript on the command line, as simple as that. So it's just a helper application to do that. So what we're going to do quickly is fill out this file so that we can actually test our smart contract using JavaScript, using TypeScript. So the first thing I'm going to do, and I'm going to just copy and paste these things in really quickly so that I can show you piece by piece what we do. So the first thing we do is we import the Legos library. We import some components from the ethers library, and we import a file from the local directory called coven config. And that I've already filled out, which is basically just some basic settings for the coven network so that I can override that in the Money Legos framework in order to test this on coven. All right. Then I grab the artifact so that I can then use that to create our contract. So I grab the address, and then what I'm going to do, I'm going to just copy in a bunch of things that set up the actual contract instance. So here, so I grab the provider. This is just a quick way, a nice way in ethers to grab the coven provider. Here I'm getting the wallet primary key that I want to use. I've got that set in my env file. You'll notice in the repository there's a .env, an env that you need to change to .env and then fill that out. It's pretty straightforward. Put your wallet private key in there. And then I create a new instance of a wallet using the private key and the provider. And then finally I can create a new instance of the contract here using the deployed address, the ABI of the contract, and the wallet instance right there. Okay, then I do a little bit of hackery, which is basically to override the DAI-coin mainnet address to the one on coven. I just did it like this. I mean, I could have hard-coded it. I could have done it in a million different ways, but I just did it like that. It would be nice probably in the future if the Legos library actually supports other networks, and perhaps that would be something I can contribute to on their repo. But for now, they only support mainnet, so that's why I've had to do this. This is the main function now. So basically what happens here is we execute the flash loan, and hence we execute the arbitrage. So this simply calls initiate flash loan. That calls the contract method, which is defined here, down here in the contract, initiate flash loan. So that is calling that method, right, in the contract. And so what I can do is go back to look at that. Okay, so, and the method takes two parameters. It takes the address of the asset that we want to borrow, so that is DAI coin, and the address is set to the one on coven. And we want to borrow the amount that we want to borrow. In this case, I want to borrow 1,000 DAI. So, and the reason why is because we use parse ether. 1,000 is again because DAI uses 18 decimal. And we pass along the gas limit. And then I output the transaction. That's the issued transaction. It's not the completed final transaction, because we have to call transaction wait and then get the receipt. And then I take a look at the receipt, and then I take a look at the transaction hash so that we can then inspect that in the Etherscan. So let's take a look. So we don't need to use truffle. Okay, now we can execute the TypeScript to try out our flash loan and arbitrage. So we can run ts node and point to the TypeScript file that we just made, and we can basically see if we make a profit or not. So we should see the this is the transaction request payload there, and we should see the receipt and the transaction hash. Okay. Actually, we don't. We just see the transaction failed. That's okay. We can take a look at the transaction hash and see what happened. So we've just put this in here. And this is the Coven Etherscan. Okay, so it failed with there's no profit reverting. Okay, well, let's try a smaller amount. So I'm just going to try it with one die. The beauty of having the script like this is you can just change parameters and rerun it, see what happens. So let's try that. Of course, I could also swap the exchanges around and see if that works. Okay, that worked because I can see the transaction hash at the bottom here. So let's have a look at that in Etherscan. And what we should see is the full arbitrage output, and here it is. You can see here that we borrowed one die, we changed it, we swapped it for basic attention token, we then converted it back to die again, and we made a small profit. So that is it. So if you're interested to know like where the Uniswap exchanges are that I'm doing this arbitrage against, this is again, it's on the Coven testnets. This is not mainnet. These are test exchanges. This is test money. But the two exchanges that we're using is over here. We've got this Coven Uniswap 2 and this one here as well. So these are the two exchanges that we're actually interacting with. And the links down below in the description. These are the two maintainers of this. It's not me that put this up, but I'm just borrowing it for this purpose. So that's it. I think you can check out the Dev Bootstrap repository here. I've put all the source code into this repository. There's a full README. You can just follow the instructions and try it out. And let me know in the comments if you have any questions and you have any requests. And please hit the like button. Please subscribe. I'm going to be doing more videos. And I hope to see you again very soon. And I hope you enjoyed this. Thank you, everyone. Bye-bye.